In section 24.2, we're going to look at experiments, outcomes, and event. An experiment is a process of measurement or observation. Our interest involves experiments that can have an element of randomness or that might be considered a random process. And some things that you might not think of as random have a component of randomness in them that would make them valid things to consider as random processes. A trial is a single performance of an experiment and is known as an outcome or a sample point, and a set of n trials gives us a sample size of size n. A sample space S of an experiment is the set of all possible outcomes. Just to try and make this a little more practical, for a coin toss, that would be an experiment. Or you might toss a coin 5 times. Then you're conducting 5 experiments. And each one of those is a random event. And you might have, with 5 tosses, what would be the sample space? It might be 5 heads. It might be 1 head and 4 tails. It might be 2 heads and 3 tails. And you'd have the complete sample space that you can consider in that application. Next, we'll look at events, complements, and the null set. Subsets of S are called events, and specific outcomes are called specific events. For example, in my 5 coin toss case, when I look at the result of one single toss, that would be a simple event. The null set or empty set is a set without any elements in it. And if we have an event A in S, the portion of S that's not in A is known as the complement of A, or A complement. Another way to say that is you might have event A and event not A. Event A would be everything that is A, and not A would be everything else. We commonly depict events, but not always, but we commonly depict events on a Venn diagram. And we might have 2 events A and B. On the left, you see a case where A and B intersect. And on the right, you see a case where A and B can't occur at the same time, and those are disjoint or mutually exclusive events. So you can either be in A or in B, but you can't be in both. Whereas on the left, you could be in both in a portion of the sample space. Event combinations can be examined pretty well with Venn diagrams. For example, if we want to look at the event intersection of a case where we're in A and in B, we can depict that quite well with the shaded portion of the Venn diagram shown on the left. We could also talk about event union, that is, what is the set of all cases where you are in A or in B. That would be the shaded portion of the Venn diagram on the right, and that's A union B, and the one on the left is A intersect B. There is a shorthand for the left one, and if you have A intersect B, that's often written just as AB. That is, both A is true, both A has occurred and B has occurred. And the only portion of space where both A has occurred and B has occurred, or AB, or A intersect B, is the shaded portion on the left side of the left Venn diagram.